In this video, we'll be studying the various strategies of using branches, also known as branching strategies, also sometimes referred to as workflows, which are the rules we will be applying on branches usage depending on the project specific. The easiest strategy you could use to get started is called the centralized strategy, which is a strategy when we all work in a single branch. Imagine that my team has 3 developers, Alice, Bob, and Eve, and we all simply agreed to work in the master branch. Nobody creates any additional branches, everybody commits directly to the master and pushes to the master, and all conflicts are also resolved in the master. How can this be helpful? If my team is not familiar with Git and don't really want to waste time to explain to everyone the details of some overcomplicated strategies, we can simply sit down right here and now and get to work using the centralized strategy. Alternatively, if my team previously used a version control, that one did not support the basic concept of branching, so where no branches at all, and now the team is having trouble understanding how branches work since they never seen them in their lives. Or my team is working at hackathon, meaning we've got only 24 hours to create some sort of product and to present it. We haven't got a spare minute to waste setting up branches, merging them, and so on. In this case, it also makes sense to apply to centralized strategy. Now, strategy one we actually already familiar with is called feature branch workflow, which is exactly what we've been doing in previous episodes about branching. Here we create a branch, create some feature in it, and then we merge the branch back into the upstream, into the branch we had initially separated from. In this case, it's master. All of our branches are popping up from master, but we can similarly branch off from a large feature. We can branch off this dark blue branch in some additional minor branches. It doesn't have a limit to the number of branches you can create. The only thing to keep in mind is what is being developed inside. So it's possible that we will be naming these branches with the name of the feature in a specific issue tracking system. Let's say we have a system where we create all stories, let's say Jira or version 1. It doesn't really matter as long as every feature has a defined index number. Then these numbers can be used as branch names. When we get a really large number of branches, let's say 500 or 100, it will be much easier for us to find a specific feature using the number of the story in the issue tracking system. There's one more interesting strategy which is called Git flow. It was presented in 2010 by a Dutch developer, Vincent Driessen. You can read his original post by following this link. The main idea is to use feature branch workflow, but with a specific set of branches designed with specific tasks in mind. Let's say that our agreement is that all code will be merged into the develop branch from the feature branches, meaning we're not merging into the master. A feature branch where a specific feature or story is being developed or a defect is being solved, it closes and it ends up directly in develop. Meanwhile, in the master branch, we store only production code, meaning only the code that we deliver to the end users, the code that we, in simple terms, are putting up for sale. This guarantees that our master will always contain only a correct, well-tested final product that can be shared. The strategy also offers the concept of hot fixes branch for working on obviously hot fixes, but this is more complex idea. You can read about it in the original post. The main point is that Git flow is a system where we use a different branch, a feature branch, but reserve the right to create some additional specific branches for specific tasks, for example, a master, develop, or a hotfix. The next strategy that's worth getting acquainted with is the integration manager strategy. It's often used on large-scale projects and especially often on projects with distributed teams where all developers cannot be gathered in a single room to have a conversation. How does it work? It's based on the concept of separate remotes. In the video dedicated to remotes, I told you about how remotes work and showed you how you can switch your remote from one repository to another. But you can also make different remotes. You can commit code, meaning we can push to one repository and pull from another one. That is the concept at the basis of the workflow integration manager. How does it work? There is some blessed repository where the only person who has permission to perform pushes is to the integration manager. This is a person with special authorization. So developers pull their code from the blessed repository and then push to their own public repositories. Afterwards, the integration manager pulls the code from specific developers, checks it, and if the conclusion is that yes, the code is good, pushes it to the blessed repository. The developers themselves do not have permissions to push to the shared repository. This can be done only by integration manager. However, as the integration manager is a single person and there are multiple developers, the manager cannot do all the work for them. It's important to have some sort of mechanism for how developer changes are added to the blessed repository, and that's exactly the thing handled by the integration manager. The manager, as a rule, rarely writes code single-handedly, but simply gathers it. The manager connects to developers' public repositories every now and then, pulls the code from them, and if the code is deemed good enough, pushes to the blessed repository. The integration manager is the only one who has permission to push to the blessed repository, and everybody else is just pulling it. That way the developers are synchronized with each other, but they receive information not simply from all commits, but only from those that were approved by integration manager. And the next strategy is very similar. It's called dictator and lieutenants. I doesn't know that many projects that where this strategy is being used, but one of them is Linux core, meaning Linux kernel uses this workflow. So what's special about this approach? It's something similar to the integration manager, except there are several integration managers and they all work at different levels. This means that we've got the same scheme with the blessed repository where the permission to push belongs just one person, that's a dictator. He can only want to push there. And the dictator makes the rules and makes the decisions about what will be added to the repository, single-handedly without asking for anybody's opinion. But the code is written by developers. However, the developers, they don't send their changes to the dictator directly for review. They first go through the lieutenants. The lieutenants are also integration managers, but simply of a lower caliber. When the developers send their changes to the public branches, the lieutenants pull them, these changes, and review them. If they decide that yes, the changes are good, they send them over to the dictator for further review, and the dictator connects to their repository of the lieutenants, pulls the data and looks at it. If the dictator decides that yes, changes are good, he sends them to the blessed repository, and from there all the participants of development, absolutely all of them, pull the code. Any story, any feature, any chunk of code created by a developer first goes from developer private to developer public, then to a lieutenant, and then from the lieutenant to the dictator. If all of the participants of the process decide that yes, the history looks good, the code looks good, only then the code makes its way to the blessed repository. The strategy works really well when we've got a very large number of project members, when the developer headcount reaches hundreds or even thousands. When we've got a big project that is open source, which is why it works so well for the Linux core. And now the final strategy that I wanted to mention, this is so-called forking workflow. The strategy is fairly simple. It is used on GitHub, and its purpose is to resolve the issue involving reading access to the records for specific developers in open source. What type of situation does that work for? Imagine that we have some open source project, let's call it JUnit, and this project has the original developer who launched this project and its original repository on GitHub. It's likely that the person who came up with JUnit won't be able to pull off the entire project alone. He needs contributors, the people who will help to do all the work, but the project creator doesn't really want to trust these people the permissions to push the project repository. And for this purpose, GitHub has a mechanism called forks. Fork is a simple copy of a repository. A developer who wants to add some update to JUnit creates a fork, and in that fork starts building on top of the data that was present in the original JUnit by adding commits. Adding commits, let's say that developer 1 added 3 commits, another developer added 3, and together formed a new feature on that JUnit doesn't have yet. So they take this feature and they publish it in their fork, which is a copy of the original repository. GitHub has this functionality called pull request. Pull request doesn't exactly what it says. It's request to pull something from somewhere. So 2 developers that have done these 6 commits have taken them and formed them into one detailed, meaningful pull request, where they wrote what they did and for what purpose and show their code, and they sent to original developer of JUnit. So what does this person do? Pulls developer's repository, checks the content, and if decides if it's all okay, then the changes, these 6 commits, can be pushed to the original repository. However, in GitHub, all of this is actually done by pressing just one button. This button is called resolve pull request or merge. And it does everything for the developer automatically, which means that there's no need even to switch remotes or anything. The number of forks in Git is unlimited. If my project gets forked, that doesn't in any way obligate me to accept these changes. But it does resolve the reading and writing issue. I don't give anyone writing permissions for my repository, but I leave a sort of workaround in the form of pull requests. And the developers have multiple free write, which means they can simply create a copy of repository and then do with it as they please. This is one of the reasons that GitHub has become so popular. This very thing that's called a forking workflow, which allows you to create a quick copy of repository and then with the help of pull requests to add changes back. So what strategy to use, it's up to you based on decision on such factors as the number of developers, how well these developers know Git, how many teams you have, and whether we are working in open source, meaning if it's closed project or a project that's stored in GitHub and is in open source. So we need to make the way internal participants contributed as simple as possible, and so on and so forth.